Good morning, everyone. Good afternoon, everyone, as well. Good evening, depending on where you are, because as we know, we have 3 different time zones here. Welcome to all to our tutorial at the International Conference in Software on Software and System Reuse 2020. Today, we will be having a tutorial session animated by myself, my colleague, Ali Ouni from ETS Montreal, and we have also Hussein Alrubaye from RIT, Rochester, New York. The three of us will take you through this journey of maybe an hour and 15 minutes presentation, then maybe 15 minutes for questions, or we will try to maybe interleave them together and achieve an hour and a half of a tutorial that will take you through our journey kind of research in the topic of third-party library reuse, which is of an interest to us since it's, as you would know, it's one of the pillars of reuse in general. So it's a very relevant topic for this conference. And we'll talk to you about the adoption, the migration, and mainly the challenges that people will face when they try to, to use APIs and adopt and migrate APIs. So today's session will have mainly two different angles. The first angle is more of a research and problem statement, and then we will walk you through a solution that we have tried to develop. Then we will have a demo where you will see how we have developed this solution from A to Z. So today's session will have two parts. First part is more of a theoretical, and we'll give you background about APIs, and then we'll walk you through the challenges that developers face when they try to adopt and migrate APIs. Then the second part of the talk it will be animated by mainly Hussein. First part will be me and Dr. Ali, and then Dr. Hussein will be animating the second part of the talk, where he will show you how he will show you live his code on how to migrate between APIs automatically. So maybe he'll walk you through the whole process of data collection, data cleaning, and then feature analysis, and then using some supervised learning, multiple models to create this recommendation between different a couple of libraries, and then he will show you how all this works from the scratch. So I think without further ado, we can start moving. So thank you all for coming. I think I made this long introduction so we can actually get more audience. If everyone's joining, then they have time to join. And then, okay, let's start.
Okay, so thank you, Mohamed, for the nice introduction, and good morning, everyone. Good afternoon or good evening, wherever you are, and thanks for attending this tutorial being virtual this year. Unfortunately, we cannot meet each other, but hopefully for the next year we can see each other. So let me introduce the speakers for this talk. So this is joint work between myself, Ouni from ICSR Montreal, and Professor Mohamed Mkaouer, and Dr. Hussein Alrubaye from Rochester Institute of Technology, who just defended his PhD 2 days ago. So he's fresh doctor to join us today on this tutorial. So I am associate professor at ETS Montreal since 2017. I received my PhD degree from the University of Montreal in 2015. I lead the software technology and intelligence research group at ETS Montreal. So we are working on different topics related to software engineering, including software re-engineering and modernization, software maintenance and evolution, software quality, empirical software engineering, and mainly the application of artificial intelligence techniques to solve different problems in software engineering. Professor Mohamed Mkaouer, he is assistant professor at Rochester Institute of Technology in the USA. He received his PhD degree in 2017 from the University of Michigan, Dearborn, and his research work includes software quality, software systems refactoring, model-driven software engineering, software testing, and mainly the application of computational search and evolutionary algorithms to address several problems in software engineering. Hussein Alrubaye, he obtained his PhD, as I said, 2 days ago from RIT, Rochester Institute of Technology. He's actually a senior developer engineer at Microsoft Corporation. He has 8 successful apps in Google and iOS stores with millions of users who are using the apps. He's working as software developer for 9 years with .NET, C++, web security, and have successfully paid tutorial at Udemy. He got Microsoft Most Valuable Professional, which is a great prize that he obtained. He is working on research to build tools and algorithms that automate the process of API migration. So for today, we will be covering different topics as my colleague, Professor Mohamed, indicated in the beginning. So we will be starting by giving some background on what is software library reuse, how we can use it, what are the basic foundations behind software libraries in software engineering. Then we will be talking about software library adoption, how we can find the library and how we can adopt it in our program or project. Then we'll be talking on updating libraries since libraries are evolving rapidly, so we need to update, we need to keep updated with the latest versions. Then we will be talking on another problem related to the migration from one library to another and how we can help developers in easily or effectively migrating. Then we will be having a demonstration by Dr. Hussein on recommending libraries. He will be presenting a case study with machine learning. He will cover all the steps that will be helpful for PhD students. At the end, we will have a summary and discuss about the challenges and give you the opportunity to ask questions. So if you have questions, feel free even to ask them in the chat box during the presentation, or even to activate your microphone and ask questions. We will be happy to respond to your questions. Ideally, we would like to have the session interactive. Okay, so let's get started. So there is always a programmer like me, or maybe like most of you as well, who is still awake at 4 a.m. and searching on Google or on Stack Overflow on a function or a library. So when an appropriate code is found, he can simply reuse it in his code. And this is actually how it looks like. So always I try to find code on Stack Overflow and I integrate it in my code. But actually, this is how my code looks like without the use of third-party libraries. Of course, this is thanks to Stack Overflow, who can or other websites that can help me to save time when I need code fragments or when I need any help. So today, most of programmers, they try to find third-party code and integrate it in their code base to help them save time and save effort and save money, of course. Instead of wasting time on re-implementing what exists, we can simply reuse this code, which is most effective. And the question is, why should I write code when I can have the opportunity to reuse libraries? This is an important aspect. So today, how it works in modern software engineering, so there are a lot of developers who are working or implementing libraries, software libraries. So developers can design, can implement tons of software libraries and release them in several existing library or package managers, such as the Maven repository or NPM or other repositories. And all of these libraries are typically well implemented, well tested, and available for free for software developers. Then software developers can simply use dependencies in their code to access and reuse these libraries and integrate them easily. And in this way, as I said, we can save time, save effort, and save money to ensure high quality software system. These libraries are typically accessed via what we call APIs. So an API or application program interface is a set of commands, functions, and the protocols that are offered by third-party libraries that programmers can reuse and build software systems. So many software systems are built through using several APIs that are available and that can be easily integrated into a project. So I think I can move to Professor Mohamed to present some basic concepts around the characteristics of libraries and challenges related to the use of third-party libraries. Maybe Mohamed, I can stop my chair and you share your screen. You have to open your microphone.
Yep, thank you. So thank you, Ali, for the introduction of APIs. And by now you realize that, yeah, when you are actually taking code from Stack Overflow and using it in your software, and I think all of us we did this at some point of time, that's totally fine. That's not plagiarism. That's not copy pasting code. That's software reuse. So yes, it's a practice. It's a standard practice of going and searching for pieces of code, fragments, libraries, anything that can help you achieve the task that you want to do. That's totally fine, and that's part of reuse. However, what we are talking about today is how can we organize that? How can we make that efficient? Because yeah, reusing libraries and APIs can actually bring their own challenges as well. And and the reason why it may be challenging is because libraries and pieces of code that we find online, they were supposed to have some characteristics that are outlined in this slide. However, it's not always the case. But let's first of all understand what these characteristics are and what do we expect from those libraries to offer. So we expect them to be useful. So yes, I mean, they should have a piece of code that can be helping me. For example, if I'm looking for a method to sort an array, yes, I expect this to be correct, first of all. You know? So whenever you go online and you go to Stack Overflow or other places, you're looking for a functionality that is correct. And also you look for a functionality which is efficient, right? So for instance, if you're looking at the sorting for instance, you don't expect this sorting to be bubble sort or insertion sort. You expect this to be more efficient, maybe heap sort or quick sort, but quick sort doesn't work on the worst case scenario. It has to be a very efficient algorithm behind that is working. So that's why it has to be useful. It has to be open. It means I can use it on my code without having any issues, without having to do a lot of casting between return types, etc. So it has to be ready for me to adopt it right away. It has to be stable. It means if I'm using a library or an API, I would expect this API to upgrade, of course, to be updated. And when it updates, it does not break my code. So it has to be stable. Also, it has to grow. If one day there's a new technology that is, for example, appearing in the language, that I want this API to be able to be up to date with those changes, right? So for example, the Java Lambda now, right? I would expect my API to be compatible with the Lambda expressions. This is just an example. So we want them to be of these characteristics. So that's what API maintainers, who are, for instance, developers like us, that's what they promise is. They say, yes, we will make sure that our libraries are useful, open, stable, and growing. And one example of APIs, if you are still not able to understand what API means, so let me break it down to you. If you have used Java before, for instance, then the Java standard class library is a strong example of an API, right? So when you are using the system, the scanner, the string classes, these classes are functionalities that are offered as an API to you because you would call different methods from these classes that belong to a package where they can offer you a lot of functionalities. So all these packages that you are familiar with, that you have been using, these are examples of what we call the core API of the Java language, right? The java.long, applet, swing, awt.net, .utility, the famous .utility, right? or the Java XML parsers. All of them are different packages that are offering functionality that are, again, they should be, again, useful, open, stable, and growing. And I guess you're already now familiar with Java, so you know that all these functionalities that Java is offering are already useful, open, stable, and also growing. So to go quickly through formal definitions, which I don't want to go into the details of this, but because we may run out of time, but a library is a set of functionality that are offered through either objects or methods or attributes or properties, right? So all these different, for example, APIs or packages here that you know in Java, they are already in the form of an API that you can call right away and use. Okay, so these are different examples. So usually those different packages, they follow a specific naming scheme, right? And you've already been familiar with this. You have seen it somewhere, somehow, but you never know that this is already a naming scheme, right? We will start with the group ID dot artifact ID dot version. For example, org.apache dot maven, and then you have the version which is 1.0.1. So they follow a specific the naming scheme where it identifies who is implementing the package, what's the artifact, and then the version of the artifact. Okay, so this is how we identify the maintainers of the API, the name of the API, and then the version. And that's how you can find the documentation of the API in case you want to use it. Okay, so a dependency means, I don't want to read all this to you, but I'm just keeping all these slides with all this information to you because I will share with you the slides after this session. That's why I'm adding a lot of text in here in case you want to go and read about this and understand. But a dependency simply means that your code, the moment your code starts calling one of the methods of this package or this API, then now your code is dependent to the API. Okay, so that's what means a dependency here, is that now your code would actually need the binaries of the API to be compiled with your code in order for you to be able to use this method. For instance, if you have a project called Hello World here, and then you may have now part of your configuration in the project that you are calling a specific library, and you may end up downloading, some third-party jar files to add in order for you to use the library. And I'm sure all of you guys have already experienced errors with missing jar files, missing libraries. You may copy a code and use it, and then it says an error compiler, oh, you are not I don't find the source of this method, right? For example, if you copy a code from Stack Overflow, which is using a specific library, and you don't have it in your project, then this will trigger an error right away. So now the notion of dependency means that we have to take also extra files in this sort of jars, or maybe Maven, depending on what kind of management you are using. You may need a dependency now. You may need another code to be compiled with your code in order for you to work. And this will give you, for example, this kind of examples, right? Now, if I'm, for example, if I'm using struts or comments or utils, etc., I have to actually add physically those jars on my projects. Physically, in case you are, of course, using, if you are making an offline project where you contain all your files within your projects. Questions, guys? Please feel free to interrupt us anytime if you have any questions. So that's what dependency means here. Now we will define what library upgrade means. A library upgrade means, in a short, and by the way, this definition may differ from one book to another, from one reference to another, from one paper to another, but at least for this tutorial session, when we talk about library upgrade, we mean moving from the same library to a different version. Same library, different version. So we are moving from, let's say in this case, struts 1.0.1 to struts 2.0.1. Okay, so we're moving from one version to another. And usually when developers upgrade their APIs, they do this in two styles. We see this happening in two styles. One is the incremental and one is their packaging. And let me show you some examples. For instance, if I am upgrading, in this example, my library, which is log4j, as you can see here, let me try to highlight, annotate this. So if you look at here, I have the group ID, which is log4j team. They have the artifact IDs called log4j. And by the way, this is a dependency file for for a project. So you can see here all the libraries that are dependent to this project or they're used in this project. You can see in this case, and this is a screenshot of a commit that has been performed by a developer where they have made uh, an, um, um, an upgrade of their library. So they were using the version 1.2.13, and now they are using the 1.2.15. And this is the link to the project that has this upgrade if you want to go and check yourself this project. So this is a real code from a real project, and you can see here how they upgrade also this library, which is from patched from this version to this version. Okay, so this is how you can see that developers sometimes they upgrade the dependencies of their libraries. They upgrade the versions of their libraries. So moving on, so repackaging is when you actually still use the same library, but this time the name of the library may have changed. For example, if you look at this example of Jetty all here, which is the artifact ID, it has been broken down into Jetty rewrite, Jetty server, Jetty servlet. So you may think that this is all different libraries, but they are not. They are the same maintainers, same libraries, and the developer, by doing this change, they do not need to do any further changes in the method levels. They just need to update the dependency on the XML file here, and they should be all set to go. Okay, again, if you click on this link, you will see how this upgrade is being performed. Now let's move to the library migration, which is an important slide and a concept to know for today's lecture. Library migration in our definition here again is when developers are moving from one library to an entirely different library, seeking the same behavior. Okay, I will repeat. When developers are taking a library A and deciding to retire it and moving to a library B, offering similar functionalities, and they have to upgrade to migrate from A to B in their source code. And we call this library migration. Okay, and as you would have noticed already, by moving from one library to entirely different library, we are looking from the old methods from the old library that are no longer available, and we have to replace them with the methods from the new library. And this has to go through finding for each method from the old library that we are retiring and removing, we have to find the corresponding method in the new library that will perform the same functionality. Okay, so it cannot be performed just like an upgrade where you just change just the version. Now you have to change the entire thing. You have to change the entire library, and then you have to go and do some more changes in the source code in order for you to perform the migration. And this happens typically instantly or delayed. So we will see some examples here. So if you look at this example, the instant migration, developers have decided to no longer use JUnit, and they want to replace it with testnj. Okay, so we used to have the old library is JUnit and the new library is testnj. As you can see, developers have already removed the dependency of JUnit here, and they replace it with testnj. Is this enough? No, because if you do this only, you will get an error, a compiler error in your code right away. Why? Because all the methods from JUnit are no longer now recognized by your system. Why? Because we have removed the dependency. We have removed the jar file. It's no longer there. So what do we have to do next? We have to go and replace all the methods from the old library with all the new methods from the new library. For instance, here, as you can see, all tests here has been replaced with test data. So this all test belongs to the JUnit. Now it has been replaced by the test data that belongs to testnj. And then we will have more changes across the code, right? All these lines in red are the removals. And this is how we are adding our other methods on the other side. For example, here assert, now it becomes assert JUnit, okay? And this process is manual. It means you as a developer, if you want to do this, you have to go and manually read the documentation of JUnit, read the documentation of testnj, and figure out what method corresponds from the JUnit to testnj. For instance, I have to read that assert in test NJ, the equivalent to it in in JUnit, the equivalent to it in test NJ is assert JUnit. Okay, so I have to go and do this manually myself. So per se, for this example, we are replacing 3 or 4 methods. We have to find 3 or more methods. If you are using 10, 15, 20 methods from the old library, you have to find 10, 15, 20, 25, 30 methods from the new library. Why? Because sometimes one method from the old library might be replaced by 2 or more methods from the new library. For example, here we have only one method that is removing, which is assert not null. Here we have to replace it with 2 methods, which are assert that and is not null. So as you can see, this is not straightforward work. This is a lot of work actually to do. This is exactly our problem statement. You understanding that this process is manual, error prone, subjective as well, because sometimes you may have multiple options to choose from. You will understand that the library migration is not a straightforward task. It would require a lot of effort, okay? And this is also motivating what Professor Ali will be talking about later, which are developers are reluctant to migrate because they are afraid of doing all this extra work, okay? So it's not an easy task, as you can see. You have to master both libraries in order for you to be able to do and perform such migration. So this migration in this slide is called instant because developers have done all this in one shot, in one commit. So they removed the entire JUnit library and they replaced all the methods from JUnit with test NJ in one commit, okay? As you can see in this example, and by the way, this is again, this is the link to the GitHub. You can go and check yourself how this migration has been performed. It's all done in one shot. So developers spend maybe a few hours, maybe a few days doing this migration, then they commit their code in one shot. This can also be delayed, you know. Delayed means that, okay, may not have enough time to do all this in one shot, then I'm going to do this slowly. I will just start by adding the new library that I want to adopt, and then I will go and throughout multiple commits, I will start replacing the old library with the new library methods. Okay, so here we are removing, we are replacing gzone with json. Okay, so we are removing the old JSON methods with the new and the JSON methods. So you can see here we are removing slowly and gradually throughout multiple commits and performing this migration, which means that at some point of time, you will have both libraries working together doing the same thing. And then you will keep gradually removing the methods from the old library all the way to removing them all. And that's when you actually remove the whole library afterwards. Okay, so this takes us now to the important thing. So why would developers, for instance, do that? Why would developers, what kind of challenges developers face when they try to upgrade and migrate on their APIs? So actually involving these frameworks is very expensive. As you can see, it may take hours, it may take days, even for migration and even for upgrades sometimes. It may take a lot of time, okay? For instance, here, and this is a reference to a famous paper that brings those examples. So the authors of the paper, they have looked at some famous upgrades. And this example is when Struts has been moved from an upgrade from 2.0.9 to 2.2.3.1. This upgrade has taken them a whole week of work. It's a whole week of them just upgrading from one version to another version of the same library. In the Linux Debian distribution, moving the Perl from 5.10 to 5.12 took them, again, 7 weeks to complete. And the question is here is why? We thought that upgrade is easy. Actually, upgrade is easy in case developers maintain and they keep their promises of of keeping their code compatible across versions. Unfortunately, this is not true. So sometimes developers do make some changes in their APIs that make breaks the binary compatibility. And we call this a breaking change. So if you have methods that, for example, disappear from the old version and the new version is no longer there, then this method that you are using now is no longer recognized. So you will get a compiler error saying this method is no longer there, even though you have just made an upgrade. And this is an example of a breaking change. And breaking changes are a famous phenomenon in API upgrades and migration in general. It's mainly for upgrade here. So that's when you can no longer use a newer version of your library without doing some change in your source code to actually accommodate for any breaking changes. I'll give you some examples. So the Eclipse, that when they moved from the Galileo version to the Juno version, they have changed one method signature here. So they removed this stop and they added stop object key. So if you are using this method and now you are upgrading your framework, you will get an error right away saying that this method is no longer there. That would not be recognized, and you have to add now a new parameter in order for you to fix this compiler error. Same thing happened with Hibernate. Hibernate, at some point of time, they made a casting. As you can see here, they used to have returned this. Now they are returning org.hibernate.query this. So they are casting the return type. And this, of course, has broken thousands of people's code. And Hibernate needed to quickly go and make a bug report and fix it and apologize for this. So they already say this is a major problem. And then that they call this, we are restoring some lost backward compatibility because the new version is no longer supporting the old version, but now they have to fix that so that people can still use the new version of the library. Okay, so that's examples. And some examples of breaking changes are whenever you are removing a method from the API, or you are changing the signature of the method in the API, or you are changing the field changes like the return types or the type of the fields. This is what we call the breaking changes. If as long as you are adding new methods to the API, you are fine. And I'm talking you, it means the maintainer of the API. Then you would not break the client's code. You would not break the code of people who are using the API in case they want to upgrade the API from one version to another. And perhaps this gives you enough background about API, libraries, upgrade, migration, and tells you how difficult this process is. So now I will move to the part where we talk about adoption, update, migration, retirement, and my colleague Ali will continue this discussion with you guys.
Okay, thank you, Mohammed, for this nice introduction on the different concepts about library migration, library upgrade, update. So let me share my screen first. Yeah, I think you covered the necessary background to understand what we will be talking about in the remaining slides on this tutorial. And there are many problems that are related to reusing libraries. So while libraries can save time and effort and money, there are a lot of problems and lots of challenges that software developers are facing with respect to reusing such libraries. And looking at the life cycle of reusing a software library, we can typically we start from adopting a library, meaning we identify the dependency of a library in our source code. And then as a second step, we need, or after adopting a library, we need to keep updated. We need to update frequently these libraries to keep with the latest technologies, with some bug fixes. Sometimes they add new features, new functionalities. And other problems are related to libraries after a period of time. Sometimes we need to migrate because the market is competitive and there are a lot of libraries that are released almost every day. So some competing libraries may appear, and sometimes it's a good opportunity to migrate from one library to another. And this is also another problem, and it's challenging for software developers to migrate completely from one library to another. And at the end, a library can be retired or from the market. So it's no longer updated, it's no longer maintained. So it could be deprecated, and developers need to avoid reusing these libraries. So this is the end of the life cycle of software libraries. So we will be covering different challenges related to all of these steps, starting from adoption, how we can find the library to integrate it in our code. Then we will be talking on problems related to update, and then we will be talking on migration, and we will be presenting, Dr. Hussein will be presenting in particular a case study on migration, and show you how we can migrate from one library to another. So let's start from the adoption, and why adopting a library or reusing a library is becoming a problem today. So the answer is that because today there are over 5.5 millions of open source packages and libraries that exist on the internet, over 37 different package managers. This is as of December 1st, 2020. So for example, looking at Go, so Go has over 1.9 million packages that are available. NPM has also over 1.5 millions, Maven also. So there are lots of libraries. While this is beneficial for developers, this is challenging also to go through long lists of libraries and select which of them is appropriate. Sometimes we try to adopt a library, then we found out that this is not the appropriate or not the most appropriate library that I can use in my code, and I end up removing the library and replacing it by another library. So it's here the real challenge for developers is how to find the relevant library and the most useful library from the huge amount of available libraries on the internet that are available in package and library managers. So this can be difficult actually and time consuming for them and risky at the same time, especially when developers are not familiar with these libraries. So it takes them time to integrate them. And if this is not the right one, it could be also time consuming to remove the library. So with this respect, we worked on different contributions in our research projects to develop recommendation tools and techniques that can help developers in finding relevant libraries that can be integrated. So we've been working on recommending APIs for web service APIs based on programmable web. We've been also working on improving reusability through identifying libraries from Maven repository, mainly for Java applications. Also, we recently in ICSR 2020, we introduced an approach called Androlib to recommend third-party libraries for Android applications. So there are many contributions actually in the literature. If you are interested on this field, you can search on Google Scholar or on Google just to find several techniques that are proposed by different researchers in different countries tackling this problem. So I will just give you an overview in the next few slides on how we can find the library in Android apps. And if you are
We
interested on the details, the technical details, please attend our presentation in ICSR.
we have
So,
a raised hand, Professor Ali.
sorry?
We have a raised hand.
Okay, so I think I cannot see if there is more.
Yeah, so
Go ahead.
I mean, if you have any questions, please go ahead.
Yeah. Since I'm sharing my screen, sometimes I cannot see messages. So,
We watch
some,
it. That's fine. We watch it from here
Yeah,
whenever
that's why
someone
we
raises
tell
hand.
you because I know you cannot see it. So
oh, okay, okay. So if you have a question, maybe you can open your microphone and ask your question. Okay. Okay. So what I will be doing, I will quickly present Androlib, what this means, and why Android applications are important, and why recommending libraries for Android is very challenging today. This is simply because today Android, as you may know, has been the dominating operating system developed by Google for mobile apps, and Android is currently experiencing a huge expansion in on its user base over the past few years. And in 2020, there are over 3 millions of Android applications that are available on Google Play Store, with over 1,000 published apps every day. Today, actually, there are several factors uh, that that help this evolution, and these apps are affecting the everyday life of billions of people on the world. And Android apps are eating the world simply. I guess even some of you, that you are actually using your mobile phone to attend this tutorial or the conference, or even you are watching on your laptop and using your phone with other uh, mobile apps, but we are trying to attract you to continue watching this tutorial actually. So there are actually several factors that contribute to the popularity of Android, including its flexibility for vendor customizations, for facility of integrating third-party libraries, along with rich functionalities provided by the Android operating system itself that can help to ease the development and the evolution of these mobile applications. And actually, this raises several new challenges for software developers, especially that third-party libraries are becoming today an integral part of the development of software apps, since using these ready-made application libraries can help saving time and effort, and allows developers to avoid re-implementing functionalities that are already implemented by other or by a third party. So today there are several repositories that provide high quality libraries like Android Arsenal, Bintray, Gcenter, and all of these repositories, they provide several libraries, from advertisement, providing graphic support, social network libraries, or mobile analytics, and many more uh, libraries. So based on some recent studies, they found that that over 60% of source code in Android applications constitute some sub-packages from external libraries. So mostly they are using libraries in mobile apps. And also they found that 90% of Android applications, they use at least 5 libraries in their source code. And for example, the repository Android Arsenal, it has over 7,000 free libraries that are available to be reused in mobile applications. And developers today, they always need to find useful libraries for so either for the initial development of an applications or during its evolution. And as users always have high expectations from these applications, they always ask for implementing new features. Apart from the rapid technology evolution in the mobile market, so developers need to satisfy users and keep their apps up to date, and they keep them useful and popular, because the mobile market is very competitive, and they do not want to lose their clients or their users. So to find libraries to support them implementing quickly and responding quickly to the user requests for new features, researchers have developed several techniques. Currently there are several approaches in the literature. Most of them, they focus on traditional object-oriented systems. They are not customized for mobile applications, while there is little support for Android apps. So most of these approaches, they use some techniques like collaborative filtering or association rule mining that try to find commonly used libraries in other apps, so that they can learn from them and they can recommend libraries. And actually, all of these approaches, they have several limitations. So while they have shown relatively good performance in recommending libraries, they are not directly applied in the context of mobile apps, and in particular for Android. In addition, one of the limitations is that existing approaches mostly recommend individual libraries, while providing little attention to the innate relationship among Android libraries that need to be recommended together, like combined recommendations. For example, social network libraries and image loading libraries are typically used together, so it makes sense to recommend them together, not individually. In addition, there is what we call the library popularity dilemma. So due to the nature of Android apps, there is a small fraction of mobile or of popular libraries that dominates the market, while some other libraries that are just emerged, just released, they have little chance to be reused because they are not actually popular. So focusing the recommendation mainly on libraries that have a usage record that are already popular may hurt some other relevant libraries that exist. And as a consequence, new published or libraries that are not popular will have little or even no chance to be recommended for to be reused in mobile applications. So this aspect needs to be considered for efficient library recommendation systems. And this is a really challenging problem. I'm wondering if you guys, any of you have any idea how to tackle this problem. So we have many challenges. We would like to recommend libraries, but we want to avoid recommending just popular libraries. So if you guys have any ideas, so please uh, you can write it in the chat box or later on email us. We want also to learn from you if you have any ideas. So, but at least to tackle this problem, so now what we proposed is an approach that we call it IndroLeap. This is a technique to address some of the existing challenges. We are not able to address all the existing problems related to library recommendations. So our approach, what it did, it takes as input a query from a developer who is searching for a candidate library, and the snapshot of data collected from currently available Android applications in Google Play Store and their used libraries, as well as the rating in Google Play Store. We would like to know how successful are these libraries that are using, are these applications that are using libraries. So then the collected data is encoded using a specific format. We are using a graph to correlate, to relate all the libraries. Then we use a search algorithm to explore all of these libraries and recommend relevant libraries based on different criteria. So here we try to address some of the problems. So we want to have libraries that are commonly used together so that we can make sure that these libraries are compatible since they are used by other apps. So this can give us more confidence that there will be no problems related to compatibility. Then we attempted to diversify the libraries because it does not make sense to recommend several libraries from the same application domain. So we'd like to have variability in the recommendation list because developers are unlikely to go through a long list of recommendations in order to find one relevant recommendation. And one of the important criteria that we consider it here is that we try to filter mobile applications based on the user rating. So we would like to learn from applications that have or that already received high rating from the users so that we can gain knowledge and learn from them. So I will then the algorithm, the search algorithm will return a set of libraries that are considered as optimal, and we used a ranking module in order to rank them. So in the then these libraries will be returned to the developer. So I will not be entering into the technical details of our techniques, so that we would like to keep only the high view idea, the basic idea. So we used an algorithm that is called the non-dominated sorting genetic algorithm, NSJ2, and we encoded our solutions here. First, we encoded the data. Our input data consists of collected Android applications and their used libraries. As you can see in the table, we have in the rows the mobile apps, and in the columns, we have the libraries. So we have 0 or 1. 1 means that application 1 is using library 1, and 0 means that application 1 is not using such library. And then we use the specific graph-based encoding to facilitate their exploration in the recommendation module. Then to represent our solution for the search algorithm, we used a vector, and in the vector, each dimension represents an Android application that could be recommended. Then the search algorithm will refine, will try to evolve this solution in order to find an optimal vector that has the most relevant libraries that can be used for, or that can be recommended for a developer. And as I mentioned earlier, we used different aspects. So we try to find libraries that are commonly used together as a first criteria. Then we attempted to maximize the diversity of functionalities among the recommended libraries. And also we wanted to reuse libraries from successful apps. We only consider apps that have high rating from users.
Yeah, thank you, Ali. Just that you know, we are at 8:55, so we may want to go
Okay, so I
later on
think
a
we
bit
have
fast on.
to go quickly on
Yeah.
this. So to evaluate our approach, we considered here a data set that consists of over 2,700 apps with over 900 libraries. And we compared our approach with existing techniques. So we found that actually we can have an accuracy in a recommendation, a precision of 78% and a recall of 81% in recommending relevant relevant libraries. So we can found our outstanding library. However, the problem now is how to manage all of these libraries, having several dependencies, and you know, each library needs to be updated frequently. This can be easily turned into a mess. So we need some to take care of all of these dependencies and keep them up to date, keep them well organized, and keep all of them under control. Of course, we need to be able to maintain our system. And one of the problems that are related here is how to keep updated, how to update or facilitate at least updating libraries in the context of software systems. This is not an easy problem, and several researchers have attempted to address this problem. And one of the studies that we conducted is about studying how developers update their libraries, or if they are updating their library dependencies or not. This paper was published in 2018, but recalls an interesting study. We covered over 4,000 software projects that are mined from GitHub that reuse 2,700 libraries, and we attempted to check several aspects. So the first part that we wanted to assess is to what extent are developers updating their libraries dependencies? So is this a practice actually? Are developers willing to frequently update their dependencies or not? And here what we found is that developers, while they heavily depend on libraries, most of systems, they are rarely updated. They don't update libraries. And we found that systems are less likely to upgrade their library dependencies with 81%, with over 81% of systems, they remain using a popular but old libraries. They are not upgrading. So we wanted to further investigate this phenomenon in a second research question, and we wanted to understand to what extent some awareness mechanisms like announcement of a new release or security advisory, sometimes some libraries, they can have some security problems. So we found that two patterns with popular libraries. So either there is a consistent migration to a new version, or some preferred libraries versions are still preferred. They do not want to update. They want just to use an older library. And also it was very surprising that we found that developers are generally non-responsive, even with security advisory. They tell you that your library is not secure, you have security vulnerabilities, but developers uh, um, are not willing to update, which is sometimes due to maybe incomplete patch with a new version of the library, so that developers wait for more stable version, or a latent security advisory. This could be caused. This is some of the patterns that we found, and maybe I think I can skip them because we don't have enough time to talk about them. This is another interesting case with common B-Util libraries, the version 1.9.1. So as we can see from the figure in the red color, there was a problem, security advisory in April 2014, so that developers started to move from the library to the next version, which is 1.9.2. But here, as you can see, there's still a significant number of, let me just open my, so here, as you can see here, there's still users that are using the risky libraries. And this is also surprising. Even they know that this is a problem, they still use the library and they do not want to migrate to the new version, which is secure, where the bug, where the vulnerability is fixed. So we wanted to understand why developers actually, they are non-responsive even to security advisories, and we found that 69. So we had an interview with 16 developers, random developers, who are using the Commons Bean-Util library, the library that has the security vulnerability, and we found that 69% of developers were unaware of their vulnerability dependencies, and they proceeded immediately to migrate to a safer dependency. And more importantly, we found that developers indicate that they did not update because they have other priority in the project. So updating the library is not a priority for them. They are busy implementing new features or doing other stuffs, and library is not something important for them. So this is based on the interview with developers. And then we found that updating libraries, developers indicate that this requires an extra effort and requires an added responsibility that they do not want to take. So just to sum up all of this, based on this study, we found that generally developers recognize the value of third-party libraries, but at the same time, they recognize that libraries age over time. Generally, their principle is, if it doesn't broke, don't fix it. Just keep the library as long as it works. I do not want to invest time and fix it. They are likely to be lazy when it comes to updating with the latest version, and they informally assess the benefits of updating while looking at their priorities in the project, even when dealing with vulnerability risks. But today, still, there are several mechanisms and several ways to check for security dependencies. For example, the Cinco, which is an open source platform that helps developers in automatically finding, prioritizing, and fixing vulnerabilities. There are many other repositories, and more interestingly, GitHub today, it uses a new security alert mechanism. Sometimes from your repository, you receive an alert that indicates that your library dependency is risky. So when GitHub identifies a vulnerable dependency, it generates a dependabot alert and displays it on the security tab in the repository. So I think that's all from my side. I keep with Mohamed to finish the part regarding migration, which is a very interesting and challenging problem. And later, Hussein will present a case study on this.
Thank you, Dr. Ali. That was very interesting insights about how developers are reluctant to migrate, and we knew that this is a problem right now, and that this is not going to be manually easily applied. So us in this call, we have like now 43 participants. All of you guys are either master students, PhD students, maybe professors. All of us, we are doing research to help developers have better life and have users have better life. So you may tackle this as a research problem, right? So if this cannot be easily done manually, and developers are afraid of losing time to do that, why can't we try to do this automatically, right? So that would take us to maybe one way to do that, right? If you want to upgrade and help them with updates and with upgrades and with migrations, then how can we do this automatically, right? So now as we are defining this as a problem, as a search problem, we have to kind of give what is the problem statement. So our goal here is to migrate from a new to a new library which may have better service, etc. For instance, we want to move from, again, JSON to GSON, TestNG to JUnit, right? So we want here to go from, for instance, JSON to GSON, which are two different libraries. And to do that, we have to be able to tell developers, if you are using the put method, let me try to highlight it here. If you are using this put method, right, from the JSON, you have to replace it with this add property from JSON. So now this is becoming our solution, okay? We try to find this automatically, okay? So the problem is, how can we do that, okay? So how can we do this? This is becoming a difficult problem now, okay? So this is how we formulate our research problem, is we try to do that. So our solution would be to take the methods from library A, okay, and methods from library B, and then come up with a way, an algorithm, a solution that will tell us if you are moving from library A to library B, you have to replace the method from library A with this one, and then the method from this one to this one, etc. Okay, so as you can see here, and this is me maybe talking to you as, you know, as someone who has already seen a lot of presentations from students, it is really important for you as a student to explain to the audience when you are presenting your research work, what's exactly the problem and what is exactly your solution by showing the input and the output. So in our case, we're trying to solve the problem of recommending automatically what methods from the old library that have to go to the new library, right? So this is our solution. Our solution would be anything that you can propose. You can propose deterministic algorithms. You can do some search-based algorithms. You can use machine learning, like Hussein will be showing in few minutes, okay? So actually he will start soon. So, so this is the solution that we're trying to propose here, is we will use machine learning to actually learn the appropriate mapping between the methods of the old library and the new library for the purpose of recommending them to the developer, and say, if you want to go from library A to library B, you have to do the following mappings. Okay, so this is how in your research you have to formulate your problem. Formulate it in a way to make it clear for the audience, and then you can propose whatever solution you want. Okay, so in the following slides we will see how Hussein will be implementing a given solution that I'll tell you about it quickly. So in this slide, I'm explaining now, you see the solution, which is in here in the green box. Now I have opened that solution to break it down to this diagram. Okay, so this is how our solution now works inside. Okay, what we will be doing is we will go and manually analyze here and collect thousands of projects that have done migration. And then we will collect all the methods that has been added and removed from those migrations. And then we will use that information as a training to a given model that will later on do the same process and recommend for two new libraries what are the mappings between them. So what we have done is we have done some data mining. We collected a lot of projects that were witnessing migrations between different libraries. We have seen what methods has been removed, what methods has been added, and then we use that as a training to our model. Okay, so now our model can learn from those previous migrations, and they would be able, the model now is able to say for these two libraries how kind of mappings that can happen between them. This is our solution in a nutshell, in a very high level. I will not go into details of feature analysis, etc., because I would know Hussein will do that live through when he's showing the Azure platform. So he will talk about those details, but just to give you the big picture, here we want to, again, be able to say for these two libraries with two different sets of methods, how can we map between them? Okay, this is the solution in a nutshell. This is how we process the solution. And now I would move to and give the link to Hussein to actually show you how we implemented this solution in the Azure framework. And he will show you how this Azure works, and how he will give you some presentation also about basic machine learning as he was doing performing this whole solution. So please, Hussein, go ahead.
Thank you, Professor. Thank you, Professor. So let me just share. Okay, screen one. So how many minutes do I have? 20, something like that?
20 minutes, yeah, 20 minutes, 30 minutes, try.
Okay,
Yeah.
that's good. So hi everyone, my talk will be mostly like, think about you're a PhD student, master's student, or even professor, and you don't want to spend time on learning how to use existing libraries of the machine learning libraries to apply in your code. So the tool that I'm using today is like Microsoft Visual Studio. It's a very visualized tool. You could just put your data and do different type of processing on it without single line of code. So you don't have to have experience in code. And I think this was very fair decision from Microsoft and Amazon. Like there's a lot of people, they don't know how to write code. So why they should learn how to write code? There are some people from statistics, so they just could use some models. So that's what I'm going to do. What I'm going to do, like I will bring a data set, which is from my research. Then I will show you how to clean the data, then how to apply some like principal components, how to divide your data to training and testing, how to train your model, what type of models you can use, then how you tune your model, how you could do cross validations. If I had some time, I will talk about the text processing. We'll see where we go. So this is the portal. It's free. Anyone could use it. So I will just go to my experience. Should have Outlook account to be able to use this portal. So what first thing I'm going to do, I just upload my data set. So what I go to do here, the data sets, and I will add a plus. I upload my data set. The data set, I have it in my desktop. So this is my data set. And you see the CSV could have different type of data sets here. I would just upload it. It will take a couple seconds to upload the data set here. And I will visualize the data set for you. It's just an Excel CSV file. So if I just go here, CSV file has different features and the data for these features. So see, look to it, like you have, for example, these columns from which library to which library, from which method to which methods, and these different features. So from X1 to X9, this is just a features from one domain. I don't want to go to details to make it confusing for you. And I have these features starting from like 1 to something like 300 something features from other domains. So what I want to do, I want to just use this data sets, learn from it, build a model. When there's two methods coming in, to the model will tell me if they mapped or they don't. So
So
now,
just to give them an overview of this. So if you go back to that file, Hussein, because I think students may not understand exactly what these files means, but I can quickly walk them through this. So so here, what we have here is when we did the migration, or when detected the migration between developers performing migrations in the source code, we look at all the methods that they're using, and we have some similarities. We measure some similarities between them. Like, do they have the same return type? Do they have the same name? Do they have the same documentation? So we are measuring. So all the values you see in these columns are different similarity measurements between two given methods. It can be 0 or 1, like for example, the J:J. If Hussein, can you highlight J:'J? Or I don't know, it's like, or colon H, for example, colon H. Okay, so here, for example, do they have the same return type? If, for example, those two methods, they both return void or return int, so you will have 1. If one is returning string, one is returning int, it becomes 0. This is just an example. And then we have different measurements of how similar is the documentation between them, how similar are the the parameters of the method, etc. So if they have the same number of parameters, it's maybe a strong similarity. If they don't have the same set of parameters, it's not. So we are kind of taking multiple methods and we are comparing between them and how similar they are, okay? And we're defining these as different columns of similarity. Hussein, you can continue now.
Yeah, so, okay. So I wouldn't save this one here. The data set already now in Azure. So I will just go here and click experiment and I click new experiments. If you have not created a project, we'll ask you to create projects. This is different samples. You could use them. I would just create empty one. So what I do here, the data set, I will just, where's my data set? The last data set I just uploaded was something like ICSR, this one. So if I just want to visualize the data set for you, again, you will see what you just said in a second. You see these columns and you see these values in every column. You click on every column, you see the range of the values and these details you want to see, you see them. See,
Can you go back in the beginning? Yeah, so in the beginning again, I'll be interrupting you a few times just for you. So as you can see here, we have the from library to the new library. So again, these are the libraries that we are going from and to. Like for example, this is EasyMock to Mockito. And then you see the method A, the method 2, again, from what method to which method, and then you see all the different features. Yeah, thank you, Hussein. You can keep going.
So first of all, you see, I want to build a machine learning model. So these texts, I don't want them, these 4 columns, from to method 1, method 2. This is just for as a background, but I want just the columns that has numbers. So I want to exclude these 4s. So what I do here, I just say, select something, select columns from the data sets, and I just plug this one to this one. Then here I click which one I want to. I want to just here I say all columns, just exclude from, exclude to, exclude this one, exclude this one. So then I hit it. Then I will just click simple run. Now you'll see new data set. These 4 columns are going away. Now, what the second step you will think about, like, okay, what if I have a missing data? So before that, let me just show you these results. You see now these 4 columns gone away. So now you no longer have these from library to library. You just have these features only, and all these features. And by the end, I think there's supposed to be a column where it's output. Should be somewhere somehow. Show you like how the output columns show you how similar they are. So yeah, this is all these columns I have them. First thing you will think about when you have a data set, like the data set may have a null data. So you use something like a clean missing data. So what you do here, just plug it. For example, you think one of the columns, let me assume, like, I think like, well, not this one, I will, oh, this is a lot. We just click select column. Think about you think one of your columns, let's assume output one has some nulls. So what you want to do is say, okay, I want to replace all the nulls with the mean value, with the medium, with whatever. This is a technique like for you to just whenever you have a data set, you need to put you don't want to have a null in your data set. But I'm sure my data set doesn't have any null, so I wouldn't care about cleaning missing data. But if you have a missing data or empty data or nulls and you want to replace them with the mean in that column or the medium or whatever, just use clean missing data. And now if you look through my data set, my data set has numbers in different scales. So see, this one from 0, this one, the data, they are not in the same scale. Very important to put your data in same scale whenever you want to do a machine learning things. So I would say normalize data here. I will look for something normalized, and I will say, okay, I will plug it. And which columns I want to pick? Well, I want to pick everyone, all columns. I just pick all of them here, all of them here. If they are not picked, they will see them here. So I want to just select all of them. I want to normalize all my columns. I think except one column, I don't want to normalize it, which is the output. You don't want to normalize the class. So I would just keep this one here. You see, I could change things using, I could do this in this way, or I could go here, and say, no, I don't want to do that. I want to do it in a different way. You could, I will tell you what I mean. So if I just click here, I say, no, I want to select all the column, exclude the output. So that's mean, okay, I want to normalize all the columns except the output. Or I could use this way that I just showed you. So all the column except the output, or I could use this way. It's just a different way of doing your work. So that's mean now the normalization will be applied on all the columns except the output. So what type of normalization you want to use? So I would use z-score. You could use min-max. You could use different type of normalizations. So I would just hit it, run. You will see now all the data will become in one scale, which will be very helpful. Now, what next? Like I have my data set, all my data now in the same scale. And I'm sure I have, like you see, this is all of them now in same scale, which is good. That's what I'm looking for. What I want to do, what I want to teach you here, something about like principal component. Based on this data, you see like there is 779 columns, which is there's a lot of columns coming from source code, not domain. Well, I don't want to talk about coding here. I want to cover the problem as a machine learning problem. So I have two domains, like around eight of the columns coming from one domain, like and around 600 columns coming from different domains. You don't want to combine them in one way because now you will have a lot of like overfitting issues. The model will not learn correctly. What I want to do, I want to say, okay, I have 9 columns from one domain. The rest 600 columns, I want to represent them with less number of columns using PCA. So instead I have 600 columns, I have 5 columns, and these 5 columns represent the 600, which is the PCA component. So I'm principal component analysis. If you're not familiar with the principal component analysis, just Google it. So this is my data sets. So now which columns I want to pick? I want to do principal component analysis for them. So I would pick everyone except this. I would pick anyone from this one. All these, see all of them, they are from 2 something, these columns. All these columns, I want to apply principal component analysis. So instead of having all these, see how many columns I have? I have 768 columns. I want all these columns to represent in 5 columns. Just I want to, and here, how many columns? I say 5. So again, if you are not familiar with the principal component analysis, just Google it. You will see how it works, how you could give it multiple columns and just scaling your columns and keeping same. There's a lot of example about how to use it. So if I just visualize my data set now, you see how many columns I have. I have x1, x2, x8, x9. I have this different columns. I have the output, which is have 2 values, which is either 1, which is mean true mapping, 0 is not mapped. And see, this is 5 columns. Did you see like the 600, 700 something column? I just represent them with 5 columns only. That's my goal. I have 5 columns from one domain. I have another 8 columns from different domains, and I have the output. It's just, this is a lot of research I did to get to this point, but the goal for me here, I want to teach you like you could use a principal component as easily in Azure.
So
now,
just again a reminder, because I think it's always important to remind the students and whoever is not familiar with this topic, the output here means 1. It means we have found that these 2 methods, they are replacing each other. So one method replaced another. And 0 means these methods that would never involve together in one replacement. It means, again, 1 means there is a mapping between this method and this method, and 0 means there is no mapping between them. Yeah, go ahead.
Yeah. So now I have very nice data sets. It have a column, name it 1 or 0, and it have a features, which is these features from x1 to x9. I have this one another feature, and I have these 5 features. I could just build my model, submit my data to training and testing, and I just do whatever I want to do. So what I will do, I would just submit my data. So a principal component analysis. So here, how you want to split your data. This is very important. Like there's different way to split your data. You want just like, for example, I want 70% go to the training, 30% go to the testing. Sometimes you don't want to split them based on the range. You want to split them based on regular expression. For example, I want only the column name, for example, whatever. The column output has 0. Well, this you don't want to do it this way because you don't want to do this here in this scenario. But now in this case, only the column output that has a value of 0s would go to the training, and that has value 1 go to the testing. Sometimes I do it like, for example, I say library. So the library, and I say, okay, only JSON. That's mean only JSON go to the training, and all the other libraries go to the testing. This is just I want to tell you there is a possible thing to submit your data. You don't have to do 17 and something. But for this example, I was 17. I would random seed. You know, was this in machine learning? Like whenever if you give it 0, always whenever you run it picks same columns to testing, same columns to trainings. But if you do random, it will pick every time you run it. Always pick randoms randoms rows to the training, randoms row to the testing, columns stays as they are. And specify testing, testify separate. This is very important because how you want to separate your data set. I always make sure your class will be the certified separate, because if you don't do that, maybe your testing set will have only class A, and now you have overfitting issue. Or your testing set have only, because it's a random process, so it will have only class B, and that's not fair. When you pick this option, make it true. Whenever the data set gets submitted to training and testing, it will make sure the submit is fair. There is enough number of first class went to the training, enough number of first class going to the testing, and same thing to the second class. So I will just run it, and we'll see how the data now look like. As you can see now, I should have my data set gets split to 2-part, training and testing. Well, I said 70%, that means 70% should go to the training. Hopefully it's not go to the testing, whatever. We'll see. This is 2 columns, result dataset, result dataset 2. It will just get sometimes to split this data. But again, see, these settings is very important. This complete topics you will learn them if you take a machine learning course about like how you specify split your data, how randomly things. So you see now I have 2 data sets. So dataset 1 should have 259 rows. The dataset 2 should have the rest. Should have 111. See, this is just how we submit. If I say 80%, you know what will happen. 80% from the data set will go to the training, and 20% will go to the testing. But always, as I told you, because I picked that option, it will make sure enough fair numbers went to the, from every class went to the training and every class went to the testing, because it's for I sure if I just select output, you see, you have fair number from 2 classes went to the training, to the testing, and fair number of 2 classes went to the testing. Here, because I'm using 2 classes, you maybe use multi-class, is different. If you don't do the sets of these options, if you don't enable it, you will not get fair numbers. You may get randomly all the element in the testing from a class B. So make sure you do this. So I have
just
here
one reminder for the audience to attract them more is that by the end of this session, we will also share with you this model. So you should be able to take this model and run it on your machine. If you have, of course, the Outlook account or Hotmail account, anything with Microsoft related account, and if you're a student, they will give you this for free. So by the end of the session, I send an email to the attendees and share with you this link, this model, and you can run this model on your machine. You can try it your own data set. You can try different things. So please, you can still, as long as you pay attention to Hussein, then you can later on update your model the way you want. So I'm just letting you know that I'll share the model with you later after this presentation.
Okay. So now I have 80% in the training. I could just use a train model. So I want to train my model. I just get, okay, let me get the 70%, pass them to the model. Now, if you look here in the models, you have a lot of models you could use. So if I just go here and I say, see, I have classification. I may have multiple class. I could use all these algorithms as a multi-class. I may have only 2 class. I could use these algorithms in 2 class. I may have a clustering problem. I use this one. I may have a regression problem. I use one. Looking to my problem, if you remember, my problem is 2 class problems. I have in my output class, I have only 2 values. So here you look, I have 2 values, 0 and 1. So definitely the algorithms I'm going to try is one of these. So I would just pick post decision tree. Done. That is. Now what is my output class? The model, the train model need to know which columns will be the output class. So I would say I want to pick the output one. And I say run. Now I will have the model get trained. Now here, what will happen here, the model will learn from 80% from your data sets. The rest 20%, you're going to use it to the testing. But here you need to score your model. How I do that? So it's evaluate or score model. And you say, okay, let me just test whatever left here and score it. So run it. So see, in very simple number of blocks, I was able to do a normalization. I apply principal component analysis. I split my data set to training and testing. I train my model, then I am going to test it. As easy as that. If you go write this one in code and or use a Python things libraries, you definitely will have some simple for loop issues that will give you wrong results. Well, unless you are very, very, very professional developers and you know you don't do any mistakes, go for it. But this one's make your life very, very easy. Now I'm just waiting. I'm waiting training. Now that you see it's just running, that's mean start learning. After run, I could just click on the model or the score model to see what the results. So I just say here, you see this is my features, you know, this was my real class, and the output was supposed to be, this is what the predicated class. So you see here it was 0, the predicate was 0, so I did the model did correct predications. It was 1, the model did 1, so that was correct predications, and you could just compare the rest. You may see sometimes that it was 0 and the model predicated a wrong value. For example, here it was 1, for example. It's supposed to be 1, but the model predicated 0. The model did the wrong thing. But this is not a right way how to measure the model. To measure the model, you need to measure the precision, recall, F-measure accuracy. So looking through this column only is not enough. So to get these values, just look for evaluate model. So just pick evaluate model. Let me just plug it. And now just run this one. So what this one do is just evaluate your model. So it will show you the precision, recall, F-measure, accuracy, and so on. So if I just click right here, I do visualize somehow. So you see, this is the rock curve. You would see here the accuracy, 93%, F-measure, F-score, 93. This is the precision, 89. This is the recall. This is the true confusion matrix, true positive, false positives, true negative, false negative. So this is like very basic things. I mean, you could do a lot here. This is just how to run a model. You could tune your model. You could easily use here, like, for example, let me just try to tune the model. Tune model, like, the reason you tune the model, if you have, for example, this algorithm, this is the parameter that's set for the algorithm. Not necessarily these parameters the best parameters the algorithm will work on. So when you tune the algorithm, it will pick the best parameters for you. So I would just say, okay, I want to tune the algorithm. So what I will do, okay, I'm tuning the algorithms. For sure, I will feed it with this one. Again, I still need something like a score model. So score model, here where I think this one, I compared with the testing. So, and now I just pass it to the evaluation. So what I did here, I say, okay, this is model. I want to tune this model, okay? So I get whatever the model I have and whatever training I have. Then I just took these data and I just pass them to the score model. Then I compare whatever tune it with whatever not. So this should be two values, one of them for tune, one of them not. So I would rather just do it this way. So first one going here and the second one going here. So you know this one the first, and you know this first one is the real and the second one is the tuning. I just swap them. You see here the tuning just give you error. So let's see what we're missing. So based on what we tune the model, for sure we tune the model based on the output class. So I will pick this one as something I want to tune my model on. What else? Like what I want to improve, like based on the data you have it. What you want? Maybe some people want to improve precision to cover more, but some people want to improve the recall. Some of them like accuracy. It depends what you want to improve. Okay, let me pick. I want to improve the accuracy. Now I mean what I for her, like how many times I want to run my algorithm, my tuning. Like larger this number will run the algorithm, the tuning will run more. Though here it will try to run 5 possible changes and try to tell you which one was best. So I would just give 5. You could change it. For example, you could make it 10 times. So that's means it will run 10.
and I will see it again how you want to run it. I always prefer random things. So I will just run it. So now this is example just to show you like, okay, this algorithm I run it, then I will run the same algorithm with a tuning, and let's see like what will be the result of the algorithm, or what will be the result of the tuning with the tuning and without tuning. It will take a couple seconds for this one to get done. Hopefully it will not take for a while, so let's just wait and see. So here we go, it's run now. I have everything running, so I will just look at the results. So let's see first how the result with or without tuning. Sometimes tuning will not lead to good results. So let me just check. So see, this is the real one without tuning, the ROP curve, and this one with the tuning. Let me look through some data. So for the real one, the accuracy was 89, and we tried to improve the accuracy, if you remember. So the accuracy here was 89. With the tuning, how much to become? Become 93. Yeah, accuracy get improved. So with the tuning. Let me see how tunings work. So if I just click right here and I say, okay, I want to show me please switch results maybe. So here, you see that you remember, before we go here, so remember this model, I mean this algorithm has this value, has maximum number of leaf, minimum number of whatever, like learning rate and this, and we said based on the tuning model, try to tune these values and pick the best one for them to improve what we said. We want to improve the accuracy. So if I just say switch results, okay, and see it, the number of leaves, minimum whatever, the right number of trees, the accuracy. You remember we give it 10 for the tuning, so to try 10 times, you see these 10s, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see it start with the accuracy 76. And with these value gets set as a number of leaves, whatever this is the random values that get set. Then try to change them and improve. See the accuracy get improved until it reach 83 as accuracy here. See the best based on current scenario, the best numbers of the leaf is 16, best number of leaf instance is 16, learning rate best number is 0.034, number of trees is 43. This is the best one for basic on current tuning. See how it's nice, how it's easy. See, so what else you want to do? Sometimes you want to do cross validations. I mean, they ask a lot for a cross validation, so you could just easily just say, okay, I want to do cross validation. I would just pick a model, a cross validation, and what I want to do with the cross validation. Usually in the cross validation, you want to feed it with the model and with all the data set without splitting the data set. You just feed it. And remember, still a cross validation. So what you want to do with the cross validation, you want to just see, okay, what is the output column? Always you need to look for the output column. So I will say, okay, what is my output column? My output column will be this one. Okay, the output. This will be what I'm looking for. And I just run it. And but remember here, like it is a cross validation. By default, it gets set to I think 10. You could change them by define number of false. There's another item you could just include it. I mean, this is the default setting. It just cross validated by 10. But if you want like 5 false or 7 false, still there's another one for the false. You could just divide how many false you want to have. Yeah, this will take again a few seconds to generate the results. So let me wait and come back. Now if I just click on the cross validation, I say, okay, show me the false. So if I just click here, you could see like it's by default 10 as I said, fault 0, 1, 2. So if you see for every fault you have the accuracy, precision, recall, or all these details. So you see like this is the accuracy at every fault. It could be 89, 80, whatever. Fault number 1 is 86, and at different faults. Here's the mean is 84. It's very important doing cross validation. You want to see what the average accuracy at every fault, because if you see like one of them, like for example, if you see one of them like for example 44 or all the rest 80, that means you will possibly have overfitting issue. So it's very important to go through cross validation information. So yes, saying that, I just try to show you the basic model, how you create it, how to tune it, how to do cross validations. There's a lot to talk about. Sometimes you have a text, you want to process the text. Remember, there is complete library here for processing the text and import it to the machine learning, such as using K-phrases, Enneagram, feature hashings, LDA. pre-processing for your text, such as lematizations, remove stop words, and all these things are there. You just could just plug them and use them. So yeah, that is for today, and we'll go back to Professor Mohammed.
So yeah, thank you everyone for attending, and thank you Hussein for the demo that you have made. And again, if anyone wants to see more details about the work, the data set, the tools that we have used, please go to migrationlab.net and you will find all the information that you want, including the following video that I want to play right now, which, as you can see here, you can see all the mappings that we have detected in using our tool, different methods going to different potential methods from the old to the new libraries. And all this, as you can see, is in a visual, nice visual animation that will tell you exactly how everything went. So um, yeah, thank you again for attending, and let's move to the demo. We've already done this demo, so we are good to go. Again, we have already, in this tutorial, we have gone through adoption, update, migration, and retirement, a lot of different sessions, and I'll let my colleague Ali talk about the different contributions of today's session.
Okay, so thank you everyone for attending. This is the end of the tutorial today. I guess we covered the various aspects. We started by recalling the basic background to understand how to reuse libraries in software projects. We also covered some challenges related to adopting or selecting a library to be integrated in a software project, and then we went through adapting or updating libraries to upgrade to newer version. What are the challenges? We have seen that developers are reluctant to update their libraries because you want to avoid the extra work and the extra responsibilities and the possible risks that can be related to updating. And this recalls for the need for efficient tools to help developers to update automatically their libraries. Then we went through the technique that we developed to help developers to migrate from one library to another in order to help them efficiently and quickly making migration by learning from current projects that exist and that they did this migration, so that we can learn from them. And uh, uh, and at the end, the tool is available. Please feel free to visit migrationlab.net. You will find a lot of details. You will find also our related publications. You can freely download our tool. You can find also several visualizations to look at and to help you also making migration if you are interested in the field. And thank you very much and have a good day.
So thank you everyone for attending our talk. Please feel free to reach out to any of us, my colleague, Dr. Ali, or myself, or Dr. Hussein for any informations. This concludes our tutorial for today. I hope that you enjoyed it. I hope that you learned something. Please feel free to share with us your suggestions, your discussions, your questions. And besides that, I hope that you will enjoy the remaining of the conference. This was our talk for ICSR this year. I hope to see you next year and have a good day.